Welcome. This is going to be a pretty short ed puzzle, and we're going to be going over solutions. We're going to be going over how to calculate something called molarity, which is just a form of concentration. And then finally, we're going to just go over dilutions. And a dilution, just to be really clear on what that is, it's essentially exactly what you do when you make Kool-Aid that's too strong. You dilute it by putting in extra water. Okay, and we're going to find out what a dilution does to the concentration. And you'll see that there's a couple of just basic algebra skills that go into this lesson, and when you get those down, this will be one of those principles that's very easy to use and easy to apply. So first of all, let's go over just a couple of definitions. Reminder what a solution is. A solution is just a mixture of two different substances, okay? And it's a homogeneous mixture, okay? If you guys remember what homogeneous means, it is evenly mixed. Next is something called the solute, and I'm going to indent this because solute is one of the components that goes into a mixture. The way I want you to think about solute is I want you to think about it as when we have a mixture of two substances or a solution, it is the substance we have less of. Okay, so an example of this would be a very common solution, salt water. Okay, with salt water, it's of course a mixture of salt, NaCl, and water, H2O. And the solute then would be the NaCl in that case, when we're talking about the solution of salt water. Okay, and then the next definition you want to know is solvent. So the solvent is, we're just going to define it as the substance you have more of. And of course, the example here, in the case of salt water, this would be the water. And in chemistry, if you're not sure what your solvent is, okay, you can usually assume that you're talking about water. Okay, it's not going to always be water, but it usually is water. Okay, okay, now that we have those basic definitions down, let's go over something called molarity. So in the lab, molarity is the measurement that we use for determining concentration or describing the concentration of a solution. Now, concentration could be all different things. Concentration could be grams of solute per grams of solution. It could be parts per billion is something that we sometimes hear, especially when we're talking about gases in the atmosphere. We talk about parts per billion of CO2 when we're talking about things like greenhouse gases. But in the lab, molarity is the most common way that we measure concentration. And here's the formula for molarity. Molarity is moles of solute divided by liters of solution. Okay? And that is exactly the same as, or the units that we use, of course. It's moles divided by liters. That'll be the units that you'll see anytime you show the molarity of something. Or we can make that even shorter, and we can just put a big M. So big M means moles per liter, referring to moles of solute, again, the thing that's dissolved, like the NaCl, the salt, divided by liters of solution. So let's look at a problem here. We're going to do two problems to show you what types of things you can expect. Let's start with a very simple one. Let's say we have 2 moles of NaCl in a solution with water that is 3 liters total. So now this is a very simple problem that we're putting out here. And all we do, of course, is we take our moles of solute, and our solute here is the NaCl. And so we've got 2 moles of NaCl divided by our total liters of solution. Now it's really important here that we look at the liters of the solution. Had this just said 3 liters of water, and if we said 3 liters of water and then we add 2 moles of NaCl to that, as you can imagine, if you already had 3 liters of water, then added 2 moles to it, it's going to raise the volume of your solution. Okay, so in this one, though, it clarifies that the total solution is 3 liters. So we've got the correct measurement for our denominator here because we want liters of solution. Okay, not liters of solvent, but liters of solution. So we've put on the bottom here 3 liters of solution. Okay, so now we divide this out and we're going to get 0.67 moles per liter. And we can essentially, this part we're just using for reference. We don't have to actually write that in. 0.67 moles per liter, which is, we write that as 0.67 molar. So the concentration of NaCl in that solution is 0.67 moles per liter, or 0.67 molar. And so what we would call this, we'd say 0.67 M, and then we put NaCl after this. Now this should look familiar because you guys have seen this in our labs where you guys have seen things that are like 6 molar HCl solution, or 6 or maybe 0.5 molar H2SO4. Those are things that we are pretty familiar with. Okay, now to take this one step further, okay, another type of problem you're going to see is you're going to see something like you have 50 grams of NaCl and you dissolve it to make a 250 milliliter solution. What is the molarity of NaCl in this solution? Okay, so how do we work this out? All right, so we go back to our formula again, and we know that molarity, try that again, molarity equals moles of solute divided by liters of solution. Okay, so we have to figure out how many moles of solute we have. Okay, oh, this isn't too bad. We start with 50 grams of NaCl. We convert that to moles. How do we convert that to moles? Who would have thought? We do our classic just dimensional analysis here, and we say, okay, NaCl is, I believe it's 58.5 grams per 1 mole. And so we're going to get something. We're going to get I'm going to move that over, 0.85 moles of NaCl. And then, of course, our question is, move this down a little bit. Our question is, what is the molarity of this solution? So we've got 0.85 moles of NaCl. So we can go back up to this little equation here. In this case, on top here, we've got 0.85 moles of NaCl. And then we have to figure out the volume of our solution. Okay, so look up here. The volume of our solution is 250 milliliters. Okay, so, but here's something really key here. It is liters of solution. So we need to convert 250 milliliters into liters. Now I know you probably can do this without doing the full conversion here. Just going to show you what you do just so that we're clear. 250 milliliters to get to liters. We know that there are 1,000 milliliters in 1 liter. Okay, so 250 divided by 1,000. Okay, you don't need a calculator, guys. 0.250. Not surprisingly, we just moved that decimal over 3 times. Most metric conversions involve moving a decimal 3 times. So now we've figured out that 250 milliliters is the same as 0.250 liters. We put that on the bottom. And now we just do the math. And we get 3.4, 1 second, 3.4 moles per liter, which is the same as 3.4 molar NaCl. All right, and so again, that is the molarity of NaCl in this solution. All right, moving on to the last concept. Now that we have the idea down about how to calculate molarity and what molarity is, let's just quickly go over an example of how you might use this. Okay, here's one really quick example. Okay, so it says you have 300 milliliters of 6 molar HCl solutions. How many grams of HCl are in the solution? Okay, let me show you how we could tackle this problem. Okay, so we know that we have 300 milliliters of this HCl solution. Okay, so I'm just abbreviating solution here. Now, the first thing we need to do is we need to convert, and I'll just tell you this right off, we need to convert to liters, okay? Because when we're working with molarity, it's easiest to move to liters, okay? So we can say on the bottom, we know we have 1,000 milliliters per 1 liter, okay? Now, the next step is we need to, now that we have converted to liters, now we need to figure out how many grams we have of HCl, okay? Now, or actually, let's not go directly to grams. We're going to go to moles first, okay? Because we've got 6 molar HCl. So 6 molar HCl is 6 moles of HCl per 1 liter of HCl. All right? So now we have now found out, once we do our calculation, let's make sure we cancel everything out. We cancel that, we cancel that, cancel that, cancel this, all right, and cancel that as well. All right, so now we know that we have 6 moles, or once we do our calculation, we will see that we have how many moles of HCl we have. And now we just need to do our molar mass, which is always how we finish these, to figure out how many grams we have. Chlorine is about 35.5 on our periodic table. Hydrogen is about 1.0. So we're going to get 36.5 grams per mole. So 36.5 grams per 1 mole. And now we are to the point where all we have to do is the math. And it comes out to be, our answer is 65.7 grams of HCl. All right, so again, this is just an example of when you say, okay, I've got 300 milliliters or 500 milliliters of 10 molar, whatever the solution is. This is how you can figure out how many grams of that solute are in that solution that you have. All right, moving along, our last part we're going to go over here is something that is a very important part of chemistry. This is going to be using a formula that we use for dilutions. And here's the formula we're going to use. We're going to say M1 V1 equals M2, try that again, V2. So dilutions, here's the scenario for dilutions. And this is what comes up all the time, okay? And I'm going to write this scenario here because we'll work through it. I'm going to keep it kind of simple, okay? The whole thing here together. It says you have 10 molar nitric acid in the cabinet. You need to make 300 milliliters of 2 molar nitric acid. How much solution from the cabinet do you need to use? All right, so the point here is this. When we're talking about a dilution, okay, we start with something up here that's more concentrated. We need to dilute it to make it so it's only 2 molar instead of 10 molar, okay? But we only need to make 300 milliliters, all right? So we need to figure out how much of the original solution we need to take and then mix with, water to come up with a new volume of solution, and then make a concentration now of only 2 molar, okay? So that's the question, is how do we get there? All right, we use this formula, okay? So M1 refers to our original solution, okay? This is the one that we have up in the cabinet, all right? Volume 1 refers to how much of that original solution we need. Then we get to M2. M2 refers to the molarity of our final solution. The 2 refers to final solution, and V2 refers to how much of that final solution we need. Okay, so you can see we've got a simple algebra problem. Now the question is, why does this work out? Why can we make M1V1 equal M2V2? Well, the reason is you'll find if you take the molarity, just like in the previous problem, you take the molarity, you multiply it by the volume, and you're going to get the number of moles of solute. Okay, so you can imagine when you dilute something, if you dilute your Kool-Aid by adding more water, you don't change the number of moles of sugar in it. The sugar stays the same. Okay, what happens is that sugar gets spread over a greater volume, and that's why it tastes more dilute. But the total number of sugar molecules don't change just because you've added water. And that's exactly what's going on here. M1 times by V1 equals moles, and then after we dilute it, M2 times by your second volume also equals number of moles. So since they both equal the number of moles, we can make them equal to each other. Okay, so we've got M1V1 equals M2V2. Let's show you how this works in the context of this problem to the right, and this will be the last problem. We'll be all done at that point. So our M1 here is going to be, so actually what we're solving for, just so we're clear, we're solving for how much solution from the cabinet do you need to use. Okay, that's going to be V1. V1 is the solution in the cabinet. V2 is the solution that you have after you've diluted it. Okay, so here's what we know. Let's actually do just some quick algebra so we can solve for V1. Divide both sides by M1, and we're going to get V1 equals M2V2 divided by M1. All right, so here we have, now we can just substitute in all of our numbers. Now I'm going to tell you something here that might seem like it's cheating at first, but when it comes to dilution problems, we do not need to convert to liters. We can leave it in milliliters, and the reason is because our units cancel each other out. All we're having to do is set up a proportion. And so when we're calculating just molarity on its own, we do need to convert to liters. When we're doing a comparison problem like this, where we talk about the original state and the final state, or a dilution problem, all we need to do is we can just leave it in milliliters. And you'll see why, because the units cancel out just fine. And as long as we're using milliliters on both sides of that, then it's going to be just fine. So, okay, so our M2, that's referring to our molarity after we've diluted this. So that's going to be 2 molar. So 2M times by the volume 2. Okay, so our final volume that we want is 300 milliliters. 300 milliliters, and we've got a little times in here, divided by the molarity at the beginning, the molarity of the solution in our cabinet. That's going to be 10 molar, so 10 M, and then you'll see here that the moles cancel out, and we'll have an answer in milliliters, which is going to be just fine. And let's do that calculation. All right, so I'm getting, as my answer, 60 milliliters as the volume 1. So what this tells us, okay, what this tells us is that we need to take, where's my 0? Let's fix that. What this tells us is that we need to take 60 milliliters from, we need to pour out 60 milliliters from our acid there, or our 10 molar HNO3 in the cabinet. We need to pour out 60 milliliters, and then we need to dilute that to 300 milliliters. So we pour out 60 milliliters into our beaker. Start off with 60. So we have 60 of our little solution that we poured out of our, we poured this out of our stock solution, and then we pour in H2O. We pour that in until we get this up to a total of, we'll say it's right here, 300 milliliters. So then we put all the water in here up to 300 milliliters, and then it's all going to mix together, and that's going to be our new solution. And we know that new solution is going to be 2 molar HNO3. I will make one note here, just because this could come up from a safety perspective. Even though this is correct from the standpoint of the math, from a safety perspective, we don't actually add the water directly into the acid, because if we do that, we could cause an explosion actually. So what we'd really do is we'd put some water in the bottom of that beaker and then put in our 60 milliliters of nitric acid and then add a little bit more water to bring it up to 300 milliliters. That would be the proper way to do it safety-wise. But the idea here is absolutely correct, that this is how you do a dilution. So come in, ask some questions on this. You have some good worksheets that cover some different angles on these types of problems. But hopefully this gives you an idea of how to use this equation, as well as just how to work with molarity. And let me promise you, molarity is something that's going to come up all the time. I'll try to tell you if we ever teach you a concept that's kind of a one-off concept that's like, hey, this is nice to know, but you're not going to use it again for a while. With this one, it's one you're going to use all the time. So get it down, get comfortable with it, and you'll find out it's not too bad to use. Thanks so much.